Okay, this is the introduction for lab number 26. We're going to be taking a look at the relationship between pressure and temperature. And if I were to just think about taking a box or a container, a sealed container with a constant volume, and I were to put some gas molecules in there, then these guys are going to be in motion simply because they have some temperature associated with them, and they're going to be bouncing off the surface of this container, and that's what's going to give rise to pressure. If I were to heat this gas up, then these guys are going to be moving faster and faster and faster and faster, and so they're going to be bouncing off the surfaces of the container with a lot more speed, and there should be more pressure. So we can say that pressure is directly going to be related to temperature. Conversely, if I were to cool this thing off, then I would slow these guys down, and there should be less pressure. Something else we can also say is that the pressure time divided by the temperature should be equal to a constant. So what we can do is we're going to open up this simulation that we've played with before, and we messed around with the volume before. Now we're going to be messing around with the temperature. So let's go ahead and take a quick look at the simulation real quick. So we have our gas, and we're going to not use volume. We're going to play around with temperature, and we're going to play around with the temperature. We're going to measure a whole bunch of different pressures. Kind of see the gas molecules have definitely slowed down here, and we can record several different values of pressure and temperature. So that's what we're going to do right down here. We're going to measure pressure, or temperature, pressure, and divide the two. And what you should see is those guys should be a constant. Then what we can do is we can actually say, you know what? We know that pressure can never be negative. We can't have molecules kind of sucking in. They can only be pushing out. So what temperature would it take for the pressure to be equal to the lowest pressure we could possibly have, which is 0? So what we can do is we can take our data right over here, and we can fit a line to it and extrapolate all the way down and figure out what the temperature has to be for the pressure to be equal to 0.